All right, this is problem number 1 from the Lagrange Multipliers homework. The problem I got was that the function f of xy is 2x plus 2y, and it says it has an absolute min and max, subject to the constraint of 4x squared minus 4xy plus 4y squared equals 1. What I'm going to do first is the Lagrange multiplier process says that I am going to first rewrite this constraint to be my g of xy, which would be 4x squared minus 4xy plus 4y squared minus 1. And the theorem says that I need to take my gradient of f, which in this case would be 2, 2, and my gradient of g would be a little bit more complicated. So I'm taking the partial with respect to x, which is going to be 8x minus 4y, and the partial with respect to y would be negative 4x plus 8y. And it says that the gradient of f is equal to the gradient, or is parallel to the gradient of g, which means they're scalar multiples of each other. That scalar is going to be lambda. So I'm going to set up this and this along with the fact that this function equals 0. I'm going to use all, or potentially use all three of those. I may not need all three. I may be able to get away with it just with the gradient. So let's start here. So we would have 2 equals lambda times 8x minus 4y. And I would have 2 equals lambda times negative 4x plus 8y. Now what I'm going to do is I notice that both of these are equivalent to 2. So I'm just going to rewrite this to say lambda times 8x minus 4y has to be equal to lambda times negative 4x plus 8y. And then I have a lambda on both sides, so that lambda goes away. Lambda will be the same regardless. So I get this expression 8x minus 4y equals the expression of negative 4x plus 8y. Solving this, I get 12x equals 12y, which means x has to equal y. Now, if I could solve just those two and find either a numeric value for x or y or lambda, then I could make some substitutions in. As it stands right now, I need to take this expression, this x equals y, and I'm going to go back into my equation up here. Okay, so in that expression, I'm going to replace either x or y with the other variables. So we would get 4x squared minus 4x times x plus 4x squared minus 1 has to equal 0. This will allow me to solve for my x, and if you'll see something very similar if we were to substitute in for y instead. This gives me 4x squared minus 4x squared plus 4x squared minus 1 equals 0. I'm just going to move that 1 over. And that gives me 4x squared equals 1, which means x equals plus or minus the square root of 1/4, which means x equals plus or minus 1/2. And since y is equivalent to x, and I do not have a lambda, a unique lambda here, then I'm going to take positive 1/2 x would equate to positive 1/2 y, and negative 1/2 x would equate to negative 1/2 y. Substituting that in, 1/2 times 2 plus 1/2 times 2 would give me 2, and negative 1/2 times 2 plus negative 1/2 times 2 would give me negative 2, and therefore this will be my absolute max, and this one will be my absolute minimum. The value we're looking for is either the 2 or the negative 2, because it says what is. So 2 and negative 2. Now, a couple of these, I did try a couple because we were having issues with it, and I tried it several different ways. Some of them, the numbers are fractions. They do work out to be nice fractions. I mean, if you can make a fraction nice, but something like 16 thirds was one of them, 16 thirds and negative 16 thirds. So they're not terrible, but there you go. Try problem number 1.